let's start with the very first talk for today. This is Martin Chaov. He's a senior software architect at DraftKings, and he's going to talk about an evergreen topic, performance. So please, take it away.
Hello. Okay. So, my name is Martin. I do software for a living, and I'll share some experience today. This presentation started as a brain dump that I was organizing for myself. So I would have something like a checklist where I can just refer to if I'm stuck or if I need to remember something. And then I decided, okay, why not organize it and present it to people? Maybe it will be of use to somebody else. So, can we put it on the screen? Thank you very much. Alright, so performance. What's our agenda for today? Well, let's first try to define what's performance, otherwise there won't be any point of discussing it. Then we'll define what to measure and how to measure it. I'll give some tooling and some short summary of what I was discussing in the past 40 minutes. I want to do a couple of disclaimers. I'm not going to do something like Google Web Vitals today, or I'm not going to show code. I'm going to be more focused on what's performance in terms of business and how we should measure it and what to measure about it. And let's start by defining it. So, what's performance? Well, performance is the accomplishment of a given task measured against preset known standards of accuracy, quality, completeness, cost, and speed. And I want to stress that speed is only one aspect of performance. And performance, again, is a business metric. So it needs to be discussed in terms of the business and the context of the business. So in terms of computer performance, besides the main ones, which are accuracy, efficiency, and speed of execution, we could measure performance in terms of response times, throughput, availability of the system, bandwidth, utilization of a variety of resources. So what to measure? Well, before we start measuring, I would like to introduce an example system, and this system is going to help me describe some of the concepts a bit easier. Imagine that we have a client-server application where our client, our happy user over here, let me see the pointer. So our happy user over here is using a client application for their device, which connects through the internet to our application server. Our application server on the back uses some database, a couple of microservices, one of which is talking to a third party. So this is going to be the system that I'm using to describe some of the concepts. Now, since we have the example system, what are we going to measure? Well, we're going to measure availability, response time, channel capacity, latency, and throughput. And following next, I'm going to give definition of each one of those. And then we'll discuss how. So, availability. Availability means the probability that the system is operational at a given time. And it's a percentage, and it's described by the amount of time a service is operating as a percentage of the total time it should be operational. So let's say that a high availability system should be operational 24/7, 36/5. It means that downtime for this system is going to be measured probably in minutes per year. Not even tens of minutes, but single-digit minutes. Well, when we're discussing availability, and we have an example system now, what's available to the user? Now, availability is measured not as a ping. So nobody cares if we have ping to the server if the application cannot log you in. So availability is measured per use case. If a login is a use case, login like registration, checkout, some storing of data, or some other business property of our system. So this is how we measure availability. Problems with availability usually arise when the user cannot reach the application server, or if the application server is too slow, or if any of the dependent resources are too slow. Such problems can arise depending on circumstances, but usually can be solved quite easily by adding more hardware, load balancers, vertical scaling, or even simple things like caching. The next thing that we're going to measure is response time. And response time is quite interesting because response time has three main components in it. So this is the time that it takes for us to generate a response to a request. It could be I/O operation that is blocking this one, or it could be related to transmission over the network. But generally, when we measure response time, we have two things. We have average response time, and we have peak response time. When we're discussing peak response time allows you to see performance of the slowest request. So this is generally taking the 19th percentile. Right, so in our system, we have a couple of places where we could have issue with response time. Now, response time, as I said, has three components. One is service time, which is our application server here taking the time to process the request, to gather the information and start responding. There is the wait time, which is our application server here waiting for the variety of services to return information. And there is the transmission time. The transmission time starts from when the response is ready, and we start streaming it back to the customer or the client application. The next thing that we have to measure is channel capacity. Now, this one is one of my favorites because it has implication in so many places. Usually this is fairly hidden from developers because it happens between the first and the fourth layer of the OSI model. This is basically hardware. We cannot beat hardware. What happens is that, I'm going to give you a simple example with HDMI. So let's say you buy a very nice expensive screen that has 240 Hertz refresh rate, and you put it on your old cable, and suddenly the screen cannot display to 40 Hertz. So it means that you don't have enough capacity on that cable to push all the pixels that you want to push. Now, channel capacity for our system could be measured in many places. I don't want for you to get the impression that channel capacity is only here. The internet is only one of the channels that we are using. But channel capacity we have here. Actually, the database itself has channel capacity between the memory, the CPU, the storage medium. We have channel capacity over here where our microservice is talking to an external one. So we have many places where we have channel capacity. Even TCP as a protocol, we have channel capacity there. We have receive window and packet sizes and things like this, which could prove to be blocking our system. So we need to understand channel capacity. And when I'm talking again, channel capacity is not only cables, it could be air. Air is a medium where we put Wi-Fi, Bluetooth, where we put 3G networks, television, radio signal. So all of these things affect your environment, and you need to be aware how your application is working and how users are using it. The next one, which could be a component of the response time, is called latency. The reason why it has its own slide is because latency is quite interesting. Latency is, the simplest way to explain it is the time between cause and effect. So right now we have latency. The light that's coming from the lights here that you don't see is bouncing from my face, going to the camera. The sensor is digitizing the image, coding it into something that is transferable, sending it to a computer which is breaking it down to packets, sending it over the internet. Some routers are happening along the way. So all of this is traveling until it gets to your screen. Once it gets there, actually before it gets there, it needs to be decoded and then displayed. And then it takes time from the screen to your eyes. So we have latency everywhere. And latency is quite important component to understand because it could be managed not only by optimization of the software and the infrastructure, but with user experience as well. Now, in our system, we have a couple of places where we can have latency. We can have transmission medium latency, which could be copper cable, optical cable, air for Wi-Fi. Speed of propagation, the further apart we are, even the speed of light is constant, so there is going to be time to travel this amount of time. Then we have variety of computers along the way, routers, switches, which have variety of hardware, which needs to process variety of traffic until it gets to you. Then we have storage delays, for example, reading from memory, from drive. And then we have something that is called last mile delays. And this photo that you see is actually taken in Sofia. And I don't doubt that people living in this building have issues with the internet, especially when it rains or especially when there are pigeons sitting on the wire. So last mile delays are the most annoying to take care of because you cannot even handle them through CDNs or anything else. Basically, you need to think about edge computing if applicable to your software application. And by edge, I mean the actual edge, which is, the device of the user, which obviously opens other issues. So In our system, we have two big potentials for latency. One is here, because this is something that we do not control. In our system, we don't know how fast the third party is going to answer, and there are different ways to handle this if it's proven to be an issue. And then we have this. This connection here we can handle by utilizing variety of CDNs, points of presence, and even some edge computing. The next thing that we should measure is called throughput. Now, throughput is a pure business-related metric. You cannot define throughput as a developer. You can define it as a business. So throughput is the rate of production or the rate at which something is being processed. For a web application, this could be rated by amount of requests that is handling. Throughput is sometimes defined by the business and can be measured in a variety of ways, but like I'm going to give an example with the cloud providers. So a cloud provider is not going to sell you 1,000 requests to do. They're going to sell you amount of time on the CPU. And how you utilize the CPU depends on this depends how many requests you'll be able to handle. Now, in our system, we can establish throughput in a couple of ways. Since our system is quite poorly defined in terms of business case, I'm going to give a few general ones. One of them could be error rates. So the amount of errors produced by our system could be the foundation for throughput. The amount of request responses that are handled or the resources that we are allocating to do our business. I want to stress that there's a difference between latency, bandwidth, and throughput. So the performance of your network and application depends on latency, bandwidth, and throughput, but it's important not to confuse them with one another. Bandwidth is the amount of data that can pass through a network at any given time. So if you imagine this as a water pipe, this is the total amount of water that can pass over 1 hour. This is the thing. A wider pipe is going to give you more water. Throughput, on the other hand, is the amount... Oh, no, don't go back. Stay here. Okay, so bandwidth is the amount of data. Now, throughput, on the other hand, is the amount of data that can be transferred over a given period. An efficient network connection is comprised of low latency and high bandwidth, and those two give you the biggest possible throughput. Okay, so I spoiled the next slide already, but how to measure? How to measure is one of the most important things that we are going to learn today. Because if you cannot measure anything or something, you cannot improve it. So performance of a computer system is not constant. It needs to be monitored, it needs to be logged, and it needs to be checked regularly. Now, to measure, we need to establish a baseline. Baseline can be only current state of the system. It cannot be the future state of the system. The baseline of our performance is what is happening today and how the system works today. Then we need to also define where we want to go, and then measure between them and take steps and improve the baseline. Now, to do that, you need to define to use some kind of methodology, and I'm going to give a simple one. First, you need to identify the test environment. What's your test environment? Is it going to include the user device? Is it going to be laptops? Is it going to be only the servers, only the backend? Is it going to include client sides? Are we going to include third-party systems into our test environment? Then we need to identify the performance acceptance criteria, then plan and design the tests, implement the tests, execute, analyze the results, tune the application, the configuration, the system, and retest. So, how do we test? I'm going to give you a couple of testing types which you can use to do this kind of, to measure availability, throughput, channel capacity, and etc. Each one of them, they kind of sound similar, but there are fundamental differences in the details. So I'm going to cover these right now. The first one, and probably the easiest one, is isolation testing. This one is not unique to performance testing. It's actually very widespread to application testing, unit testing, end-to-end testing, integration testing, and etc. This is a component of each of those. You can use it to test in isolation a specific system. So let's say to test the throughput of the database, the maximum amount of the request queue of the application server, or the speed in which the client application boots and shutdowns, and etc. In isolation, it's very easy to do this as part of your CI/CD process, which is very nice, and it can tell you that this specific component is matching their SLA. Now, this doesn't mean that as part of the system it's going to work always 100% of the time, but at least in isolation, you can say that this component surely matches SLAs. Now, the next one is load testing. Load testing is one of the simple forms of testing. It only requires you to send traffic or do requests or try to write or do X to your system. Load testing allows you to verify that your application is going to perform up to spec when a specific amount of users are accessing it. So load testing is not to overload the application. So if you expect 50% of load to the system, you should test with 50% load and verify that the system can handle it, or increase it a bit and check how it's going. There is, however, another form of testing where you're going to go above 100%, and this is stress testing. And I don't want you to confuse stress testing with a spike. I'm talking about full load, above full load for sustained period of time. This is going to allow you to understand how your system is going to handle unusual amount of traffic. And it can help you design strategies around it, be it scaling or denying access or whatever. The next one, which I really love and I'm trying to do from time to time, is soak testing. Also known as endurance testing. This one is very interesting because it shows properties of a system that you sometimes cannot anticipate. Soak testing is when you take a system and load test it over a big period of time. And I'm not talking about 1-2 hours here. I'm talking about 24, 48, a week of sustained load at 70%, for example. During this kind of testing, obviously you need to monitor the system quite well and deeply to understand memory management, CPU management, scaling tactics, etc., etc., etc. And the point of this testing is to show that the system can work for sustained amount of time without degradation. So what we are actually monitoring here is that the throughput of our system, being error rates or request responses or whatever we define, is constant and not degrading. Now, the next one that I mentioned earlier is so-called spike testing. And this type of testing is designed and utilized in order to show you how your system is going to respond to sudden change of traffic. Because when, for example, when we do load testing and even stress testing, we are doing gradually heightening the load on the system. But with spike testing, immediately we are sending like 10,000, 100,000, whatever is considered a spike for the system. We are sending it immediately and then shut it off. And in this kind of testing, we are also monitoring the system to understand how it behaves in terms of resources allocation, if something is going to break, if the database is going to be overloaded, or if the microservice can handle it, or whatever. Then is the breakpoint testing. Well, with breakpoint testing, what we aim is to break the system. And this could happen by overloading it with requests or by using malicious, specially crafted type of requests, or by doing something else, like just go and kill a microservice and see what's happening. And this kind of testing, again, if I do a throwback to the beginning, performance could be speed, but it also could be reliability of the system. So in this kind of testing, we can design and verify strategies where if the system breaks, how it will recover, how much time it will need to recover. Now, think about this like if you have a system with hundreds of microservices, what's going to happen if 10% of them go down? I'm not saying why. Let's imagine that in the data center, somebody threw some water on one of the servers and you had 10 instances running there. What's going to happen then? How are we going to recover from this? The next type of testing that we can use is configuration testing. Now, configuration I really, really like because you're not touching the code. The whole idea with configuration testing is to understand that currently what resides in our data center, is it the most efficient configuration possible. So let's say we want to handle more requests. What can we do? Well, we can introduce a load balancer. We can do 2 application servers that are talking to our infrastructure and to our third party. Now, with configuration testing, it's easy to identify if we are utilizing our resources properly. So if we have 2 application servers that can load our, let's call it backend part of the system, maybe it's okay to have them. But this could also introduce too much load on the database, or it could introduce too much load on our third-party partner. So maybe it's okay, maybe it's not okay. The next type of testing that we can do is internet testing, and this one is kind of specific to web applications. Imagine that you want to go to a new market. Let's say you are a Bulgarian company, hosted in Bulgaria, in Sofia, and you want to scale out to a variety of countries around. So how do you verify that your software is well perceived in those countries? What do you do then? Well, you do internet testing. One way to do that is to use software like, I'm not making an advertisement here, but Catchpoint, because they have on-premises servers in variety of locations, and you can test how your application is going to work there. But this is going to give you a very limited picture, because usually those services that provide this kind of testing, they actually reside in the data center of the country. They are not behind our last mile customer. So what happens with internet testing, it's quite expensive to do right. You basically need to be there. And I'm also always reminded of a case which I had in one application. It was behaving very slowly in UK, but not always. It turned out that this is really happening to specific customers of a specific ISP. And then there was no reasonable way for us to debug this. So we should fly somebody there, basically. Eventually we found a way to RDP to a machine, and we investigated what's going on. And it turned out that this ISP has 2 seconds of resolve time to a DNS resolve time to a CDN that we were using. So essentially, to handle this, we had to find a CDN that they talk to each other faster and mirror our existing infrastructure there, or at least the resources that were needed. Well, this was not a cheap fix, but again, this is something that you could see in the wild. ISPs don't care about your software. It's your problem. Now, something important that I want to convey here is that performance hides. And it usually hides in unexpected places. And when you're down to the details, when you look from your point of view as a developer or some kind of manager of a development team, it's very hard to see where performance is hiding. So then you need to actually go back, a few steps back. You need to see the system from the top. You need to understand how your users are using this system. You need to understand how the system is delivered, why, how it's perceived, how it's used, how it's monitored, and only then you can get to a place where you have improved pockets of knowledge, which then, when you go back to your reality, you can improve. And your previous conceptions might be even wrong. Now, this knowledge, when reflected to the details, it's also important to be reflected correctly. And very often you can focus and test the wrong things. For example, I've seen when we have a slow web application, for example, and developers are trying to optimize the bundle size. And that's a correct thing to do. And it will probably improve the speed of loading of the application by a minuscule amount. But you need to understand what is the real reason why the system is slow. Given the example from earlier with the ISP, even if we have 1 kilobyte of data to send, it takes 2 seconds to resolve the DNS. That's it. I cannot improve this by reducing the amount of data. Now, also tests should not be very expensive. Expensive tests means that you cannot afford to do them all the time. So you need to find ways to do testing cheap and efficient. And also time to market. Time to market is important. I don't have time for you to debug CPU dumps or memory dumps or something like this. We're losing business. If our system is not perceived well or doesn't work well, there are other customers, that are going to switch over to a competitor's system. So time to market is always important in such situations. Don't forget about performance. I know it sounds kind of obvious, but usually when the system starts performing well, everybody goes to develop features and the system degrades over time. Impossible standards. Now, a system cannot be infinitely fast because this means that it's going to be infinitely expensive. So we need to have, in the baseline that we established and the picture where we want to go, we need to be realistic. If a transaction, the most performant transaction that we have is taking 10 milliseconds for some reason, and we need to add 3 times more stuff to it, it's no longer going to take 10 milliseconds. And that's it. There's nothing you can do. You cannot beat the laws of physics. Again, performance hides. You need a specific knowledge of the system in order to be able to improve performance. Usually, code changes are not the best thing that you can do, unless they are. Caching is not everything, but it helps. And this is something that you can try immediately to verify if this is the bottleneck. If network is the bottleneck or some service is the bottleneck, you can do that very quickly. And again, adjust your expectations versus the reality. For example, a dynamic single-page application is never going to be as fast or as performant as a static website serving some text. So if you compare yourself to this, you're not going to win, ever. So, as I promised, some tooling. Half of it is paid, half of it is not. As I said, this is not an advertisement, but if you really have performance problems, you will need professional tooling to verify. I've used all of them, and I can tell that they have variety of strong sides and weak sides. They are a good start. But if you're really passionate about software development, you should have your own tools to measure software performance. So, in short, we should measure availability, response time, channel capacity, latency, and throughput of our system. Obviously, these are defined mostly by our business and environment. How we are going to measure is by doing isolation, load stress, soak, spike, breakpoint, configuration, and internet testing in case of systems that are available around the internet. What's going to be our methodology? Well, we're going to identify the test environment, identify the acceptance criteria, design the tests, implement, run, fine-tune, and start over. And it's good to ask the right questions. In what detail, what is the performance test scope? What systems, subsystems, interfaces are part of it, what are not? For user interfaces, how many concurrent users we are going to test? How much we need to handle? How many should be considered above our system capacity? What is the application workload mix? Do we have 100% logins, 20% checkouts, 30% writing to database, yada yada yada. So these questions must be answered when you're designing the test. What are the time requirements for any and all backend actions, communications, and the so-called SLAs, the service level agreement. And that's my summary. So now it's time for Q&A.
Thank you. Thank you, Martin. We have a question from Dimitar Dimitrov. He's asking, his question is about stress testing. He's asking whether it's a good idea to run it on production and what are the best practices to do that.
All right, very good question. So stress testing on production, actually it's a good idea to do it on production. The best practices is to define when your system is underutilized by your customers. So if we're talking about a website or a web-based system, let's say we can segregate part of the production servers. So let's say we have, I don't know, hundreds of servers, and we can segregate 10 of them and do stress test. And this can be derived result, and we could assume that this result is going to be fine for the entire system. Because if you think about it, if you have to stress test a system with hundreds of servers, you will most probably need hundreds of servers to generate the traffic to it. And this is electricity, heat, computers, systems, this is very, very expensive. So it doesn't make sense to stress test the whole system unless it does make sense to do it in specific cases. For example, if I'm flying on a plane, I would love the whole plane to be stress tested. It makes sense, right? I don't want only to stress test the chairs or the wings. I want the entire system to be stress tested, and for me to be sure that it can sustain turbulence, temperature, pressure loss, or whatever else airplanes need to handle. But if we're talking for a website, it makes perfect sense to segregate a couple of your production servers, stress test them, analyze them, because if you stress your entire system, this stress is going to be propagated to all the services, all the databases that you use, and everything. So financially, it doesn't make sense to do it in this way. But again, it depends on the system, and in computer science, the only correct answer is it depends. I hope this answered the question.
So we have another question, and that's about measurement. Should we measure everything, or is there like an art to it?
Is there
an art to it? Should we pick something, or should we measure everything?
Well, it depends what's everything. So when you define, going back, let me check a slide. Where are you hiding? Ah, here in the methodology. So based on the test environment, you need to identify the test environment, right? And in this test environment, you need to define what to measure, the performance acceptance criteria. So everything is a strong word. So are you going to measure the electricity input from the outlet? Are you going to measure the differences in temperature? If the server is cooled in this temperature, how many requests it can process? So everything is very, very strong word. You need to put a box, and you say, okay, I care about requests per second. I care about how many cores I'm using. I care about how much memory I'm using. I care how many IOPS I have to variety of storages or whatever. But you can never manage to measure and store everything. So it always needs to be put in context. I'm giving another example. So let's say you need to measure a business use case. The user needs to buy stuff and check out. So what do I need for the user to buy stuff from me? I need the user to verify themselves, authenticate in some way. So login, let's say. I need the user to have money in the balance or be able to pay in some other means. And I need, let's say, paying by card. And I need the ability for them to browse, select, put into some shopping cart or whatever, and then check out. So how many of these I can do per hour, let's say? What's the maximum amount of checkouts I can do or I can handle? And in this case, you will care about variety of services. So you should monitor them, CPU time, memory, traffic, request queues, if there are requests that are timeout and dropped, or everything is fine. So these kind of things must be defined based on the use case. This is why you cannot blindly measure performance and say, I'm doing this for performance. Okay, which one? Is going to give me better availability, or is going to give me better response times, or is going to work better on Wi-Fi or 3G network? So which performance you're improving by doing this for loop a bit faster?
Cool. So we have yet another question, and it's about resource exhaustion testing. For example, how are we looking for potential denial of service opportunities, and what are the best practices there?
So the best practices there is to give this to people who have experience and can handle this for you. There are many services that are providing this, and for DDoS specifically. Because resource exhaustion and DDoS, they have some overlap, but they're not the same. So when we're talking about DDoS, you should think about going to a service provider that can handle that for you. I've seen cases where one entire data center went dark because it received 35 terabytes per second UDP traffic. And just, that's it. No access to the server. It was completely overflowed. And there's nothing you can do. Like, you're not going to build your own data center and handle this kind of traffic because no application really needs such traffic. So DDoS, special case, putting it aside. About resource exhaustion, the best tests that you can do are two. Actually, three in this case. First of all, you need to do load testing to understand how your system behaves in variety of loads. These are the loads that you expect with real customers. Then you need to do stress testing to understand how the system will behave when you go over capacity. And then you need to do spike testing to understand how you're going to handle sudden bursts like this. So in these cases, you can understand how the system will behave in those three cases. So when you're talking about resource exhaustion, I assume that this is going to be more in the area of the stress test. And earlier in the presentation, I mentioned that when you're doing stress tests, you need to understand at what point you should start denying requests and access. So at some point you will see, okay, 100%, we're fine, 110, we're still handling, we can add one more application server. At 200% load, the database will just die. So anything above 150, we are going to cut. We're not even going to scale. We're just going to cut. Is it good for business? No. But again, business decides that, okay, we need to handle X amount of traffic, X amount of customers at the same time, and the system will not be able to handle more.
Cool. So we have yet another question. This one is from Victor Markov. And do you measure, the question is, do you measure team response time when production outage occurs?
Yes. And actually, specifically for DraftKings, we have hard SLAs to answer such a thing. Of course, somewhere behind in the slides, I have time to market. So time to market, as I said, sometimes the best fix is not the best fix, right? The best fix from engineering point of view is not always the best fix from business point of view. We need to react fast or we're going to lose business. That's it. It's as simple as that. Think about it this way. If you're dealing with sports betting or casino, the customer wants to bet right now. If the service is not available, they move immediately to your competition, and that's it. And they may never come back. So this is something like, especially for sports betting, your favorite team is playing now on the Champions League. They're going to play next year again, yes. And you're going to try to bet next year again, yes. But they're playing now, and you want to bet now on this game. So in this case, time to market is one of the most important performance characteristics of a company. How fast they can react to the changing environment.
Cool. So those are all the questions we have. Thank you so much for the talk.
Thank you very much.
And folks, we'll be back at 3 p.m.